Thank you, Oda. I'm Kyohei AKIYAMA. I'm working for JAXA as well as the new Japanese Analysis Center JGX. Today, I'd like to introduce the solar radiation pressure model for GNSS satellite with radio communication antenna, which affect on the shadowing effect to the satellite body. So the aim of my presentation is to construct a model of the shadowing effect for box wing model. The box wing model can describe the non-gravitational forces using the already disclosed data, which is very important for IGS community to construct and validate the model by themselves. So the concept of the model is easy to install to conventional box wing model and using already disclosed data. And the equation of my model is very simple. The effective area A bar equal to the surface area with a shadowing model effect minus the shadowing effect shown in this one. Sorry. Okay, sorry. Okay.
It's Papa.
Okay.
This is the point.
Okay, thank you. Showing this model. So the F is the simplified shadow model for QZSS reflector 1, 2, and the surface body of the plus minus X body surface. And in order to construct the model, we have to representing the direction of the sun relative to the body fixed frame of the QZSS satellite. So for the GNSS satellite in orbit normal mode, which is the attitude mode for the geosynchronous orbit satellite, the azimuth angle and the elevation angle related to the body fixed frame can be expressed in the term of geocentric orbit angle, mu, and beta angle, sun elevation angle, beta. And we have to consider the tilt angle of the reflector 1, 2 of the QZSS satellite with respect to the YZ plane of the body fixed frame. And for simplification, the shape of the QZSS satellite reflector is assumed to be the square whose area is equal to the circular reflector. And I have to say that it is very important, the gap between the reflector and the satellite body should be considered because the sunlight shines through the gap when the sun is located in the bottom side of the QZSS body. So I will show you some example of the shadowing area for QZSS3. This figure, this graph shows the shadowing area using the gap model and without gap model. So we can see the large difference using these two models. So we have to consider the gap between the reflector and the satellite body. And I also considering the beta angle dependent effect of the shadowing area because the GEO satellite QZSS3 is in the orbit normal mode, so the sun is shining in the Y surface of the satellite. So, but it is difficult to model this effect precisely. So to simplify the model, the correction expresses how the area of the shadow on the X surface cast by this central region of the reflector 1 changes depending on the beta angle. So it is quite efficient to model the beta angle effect. So from the next slide, I will show you some validation result of using the shadowing model. Where the validation is divided to the acceleration domain and the precise orbit determination, which means the position domain. The first of all, I will show you the acceleration difference of the direction of the sun in the d direction compared with the acceleration based on the very precise CAD-based model, which has not been published yet. So I used only this model only for the reference. So we can see the we can see the clear pattern in the left side of the figure, which is not considering the shadowing model. So on the other hand, we cannot see the clear pattern in the right figure. This is considered the shadowing effect, but in this figure we didn't consider no beta. We didn't consider the beta dependent model. So the slight beta angle difference this tendency is still observed, but so after applying the beta dependent model, the beta angle dependency has clearly decreased. And I will show you another result. This is econ parameter estimate for QZSS3. So we can see the clear difference in the bottom right of the figure. This is the econ parameter of the twice power revolution in the direction of the sun. So according to the graph, the econ parameter become close to 0, so which indicate our model is efficient to model the shadowing effect. So you may find the another difference in the D0, it's a constant term in D direction. Actually the offset of the D direction slightly larger than not considering the shadowing effect, but the variation depending on the beta angle is decreased using our model. Okay, so this is the result of the day boundary discontinuity. So the model improved the day boundary continuity in radial direction by 20% and no beta angle dependency observed according to the this one top right figure. And this is another result using the daily RMS of linear clock fit residual, which is computed by the fitting satellite clock with a linear function using 1 day period, because the QZSS or GNSS satellite is a high stable clocks, so we can see the clock error using the fitting with linear function. So according to the results, the SAT model improved the residuals by about 13%. And this is the final slide of my validation. This slide shows the SLR residuals using the box wing model and without using the box wing model. So actually the shadow model improved the standard deviation of the SLR residual slightly, but increased the offset. So we have to check the cause of the reason why the offset is increased using the shadowing model. So I guess some other improvement other than the shadow model is needed. And this is the conclusion of my presentation. And today I have no time to explain the detail of the model. So I will attach the detailed model end of my presentation. So if you are interested in my model, so please check my presentation. Once my presentation uploaded in the website. So I would be very grateful if you could improve the model, shadowing model based on my model I proposed. This is conclude my presentation. Thank you for your listening.